starting 11.2, finding limits using the properties of limits. I want to first talk about what limits are. If I look at the graph of y equals 1 over x, I have it right here, and I'm asking the limit as x approaches 0. If there's a little minus after it, that means from the left. If you see a little plus after it, that means from the right. Those are called one-sided limits. If I approach the same limit from the left and right, then that's what this limit would equal. But let's try this. This particular one, I'm approaching 0, which is right here, and I'm approaching it from the left. Here's a x value close to 0. Let's go closer to 0, closer to 0, closer to 0 on the x-axis. What are the y values going towards? Negative infinity. If I approach 0 from the right, that's on the right side. Now I want to get closer to 0 and closer to 0 and closer to 0. The y value here is going up towards positive infinity. Because these do not approach the same y value from the left, this limit does not exist. And it's a little tricky because infinity itself does not exist. I always say you're only allowed to answer infinity on one-sided limits. That's the way I usually state it. Now look at the example down here, this one with f of x. Whenever you see a bracket, those are called piecewise functions. So you've got to graph them in two pieces. So I have y equals x, which is this red line, 0, 0, 1, 1, 3, 3. But I have it everywhere except when x is 2. When x is 2, y is going to equal 4. So that's why it's up there at 2, 4. If I approach 2 from the left, here's something close to 2. Here's closer to 2, closer to 2, closer to 2. As I approach 2 from the left, these y values are getting very close to what y value? 2. How about if I approach from the right? This is close to 2, but let's get closer to 2 on the x, closer to 2 on the x, closer to 2 on the x. And if I approach 2 from the right, I think it also has a y value of 2. Because the limit from the left and the limit from the right are the same, we say that's what the limit is. So this particular limit is 2. The limit as x approaches 2 that's not one-sided. So to evaluate limits, you kind of have to look at them from the left and from the right. It's not the y value at that x value. It's a y value as x gets very, very close to that x value. Anyway, we're going to evaluate techniques or evaluate limits using the following techniques. 1, direct substitution, 2, factor cancel, 3, rationalize, 4, least common denominator, and 5, L'Hopital's rule, which we probably won't get to because that involves derivatives. And for me to teach you that, I have to be able to teach you derivatives first. So, we're going to be doing 1 to 47 odds and 11 2. My question is, if I gave you something like 1 over 0, we know 0 over 1 is 0. But 1 over 0 you can't do, you've always been told it's undefined. Which is kind of true. We have to lie to you in mathematics sometimes to bring you to the next level. But there is methods of dividing by 0. So give me something very close to 0, like 1/10. What is 1 divided by 1/10? 10. Give me something closer to 0, 1/100th. 1 divided by 1/100th is 100. 1 divided by 1/1000th is 1,000. 1 divided by 1/10,000th is 10,000. So as the bottom gets closer to 0, the value starts getting bigger and bigger and starts approaching infinity. So sometimes you'll see me state that a constant over 0 is infinite, and a 0, well, let's do a constant divided by infinity. What would be a constant divided by infinity? Let's do 1 divided by a big number. That's 0.1. 1 divided by a bigger number, 0.01. 1 divided by 1,000 would be 0.001. 1 divided by 10,000 would be 0.0001. So as the bottom gets bigger, the value gets smaller. So the constant over infinity would be 0. These are a couple of facts that help a little bit as far as comprehension and getting to the right values. So we sometimes can divide by 0. Where it really gets interesting is when we start talking about things such as 0 divided by 0. That's called an indeterminate form. And that's where the calculus comes in. When we start getting 0 divided by 0, that's where Newton and Leibniz come into play. Okay, again, I recommend the following order. Try direct substitution first. If you can put it directly in, try that. If it's a fraction, you might, and they're polynomials, you might want to think about factoring and canceling. When they have radicals, that's the only time you really should be thinking about rationalizing, is if there are radicals. And least common denominator, think of fractions in fractions. L'Hopital's rule we probably won't get to simply because it involves derivatives. But we are going to get a lot of 0 over zeros, and that's, again, is where the calculus is being introduced. So here's a bunch on direct substitution. Again, the assignment is 1 to 47 odds. So I want the limit of 8 as x approaches 2. Since there's no x to replace, the answer is simply 8. Now in this one, I want the limit of x as x approaches 2. So simply substitute in a 2, and you'd get a 2. How about direct substitution in on the next one? Could you put 3 times 6 minus 4, that's what, 18 minus 4, which is 14? On number 9, can you put 5 in and get 25 minus 15 minus 4? 5 squared is 25 minus 15, I think, is 10 minus 4, I believe, would be 6. If you put a 5 in, 25 minus 15 is 10, and then 10 minus 4. Yep, that's right. And 17. Can I simply put a 5 in for the x? You put a 5 in on top, you get a 5. On bottom, you get 5 plus 1. So this result was 5, 6. And even all the way up to 19, I think you can do direct substitution. If you were to replace the x with a 2, what would you have? You'd get 4 minus 1, which is 3 over 1. This limit is 3. Now, this is a polynomial. You might have factored and canceled. If you have, well, what would you have? You'd have x squared minus 1 over x minus 1, and x was approaching 2. The top would factor as the difference of squares, x plus 1, x minus 1, which will cancel with the denominators, x minus 1. So really I'm looking at the limit of x plus 1 as x approaches 2. By putting it in, you get 2 plus 1, or 3. But I think you could have substituted that in originally. Always try direct substitution first if you can. Now, if you see polynomials that factor, maybe they can be factored and canceled. How does this factor? Well, x squared minus 16 factors into x plus 4, x minus 4. X squared minus 9 is the difference of squares. That factors into x plus 3, x minus 3. x squared minus 4 factors into x plus 2, x minus 2. And I think one of the ones we're talking about would be in this one has an x squared minus 1. That would factor to x plus 1 times x minus 1. In general, if you have a squared minus b squared, that's going to factor into a plus b times a minus b, because it's called the difference of squares. So I'm going to take my numerator here, and I'm going to factor it. However, first I might try direct substitution. If I put in a 1, I get 0 over 0, which is an indeterminate form. So if I factor the numerator, and I cancel it with the denominator, that leaves me with x plus 1. What is the x approaching? 1. So if I put 1 in, this limit is 2. 1 plus 1. Now, can you factor 23? If you put 2 in on 23, do you get 0 over 0? Whenever you get 0 over 0, it's an indeterminate form. We have to do something to deal with it, including these techniques. If I factor a 2 out of the top or the numerator, I'd have this. So this whole thing simplifies to 2. So if there were any x's, I'd replace them with 2's. But since there aren't, that's what this limit equals. 25 is another factor cancel. You're going to factor the numerator. What multiplies to negative 3 but adds to 2, I think would be 3 and negative 1. This factors to x plus 1, x minus 1. So I'm left with x plus 3 over x plus 1. So what do I replace the x with? 1. And I should get 4 over 2, which makes this limit 2. There are a lot of factor cancels if there are polynomials that can factor. This one factors, but it's more of a challenge. If you want to try and put 2 in, you get 8 minus 4 times 2, 8, plus 8 minus 8. So you get a 0 on top. On bottom, you'd have 16 minus 2 to the third is 8 times 2 is 16, plus 2 minus 2, also 0. So you do end up with 0 over 0. So you might try factoring it. There's no common factors, 4 terms, so split it. What can I take out of the first 2? X squared leaves me with x minus 2. Out of these 2, I think I can take out a positive 4. That also leaves me with x minus 2. Now if I factor out the x minus 2, it's going to be multiplied by what remains, which is the x squared plus 4. Now we're going to do the same thing on the bottom of this fraction. I'm going to factor out, in this case, an x to the third. I think that leaves me with an x minus 2. If I take a 1 out, that leaves me with the x minus 2. So that leaves me with x minus 2 times, x minus 2, because you're factoring it out, times what remains after you take it out, would be the x cubed plus 1. Now after you cancel, I think you can put in a 2, and you're going to have some other value. If I put in a 2 for the x, because that's what it's approaching, you get 4 plus 4, which is 8. 2 to the third is 8 plus 1 is 9. So this one should be 8/9.